So welcome everyone again to this Smart Citizens Sustainable Design Talk that we're organizing in collaboration with the Making Futures research group. We've been absolutely looking forward to this talk and really pleased and honored to have Lapo from the WASP team that's joining us tonight from Italy. So thanks, Lapo, for joining us again. I think this is going to be really inspiring for us to understand your practices and see what we can actually implement locally here in and around Plymouth. So the way it's going to work for this talk is basically Lapo is going to tell you more about different aspects. So the sort of design aspect of the TECLA house, which you can see on the screen, hopefully, and you've probably seen it on the flyer when signing up for this event. And then he will also tell you a little bit more about the making process, so the 3D printing aspects and the use of local clay and local materials. And then he'll tell you a bit more about cultural and open source projects that the WASP team is involved in. And then after that, we'll have a comfort break of 5 minutes, and we'll come back to the space and have 30 minutes for questions and answer session. So I'll leave it to you, Lapo, to take over. I'll stop presenting, and you can start your presentation.
Thank you, Elizabeth, for the invitation. And now I try to show my screen. Just 1 second. Is it okay?
All good.
Perfect. Hello, everybody. I'm Lapo Naldoni of the WASP team. I am a member of the team that in particular is focused on architectural scale research. And with the other 3 guys, I worked on material, on the machines, and on the design of the houses, the printable houses. I want to start to the idea of Massimo Moretti that in 2012 he found WASP, and he decided to use advanced technology to help the basic need of a human. And to do this, he started from the pottery WASP. So this is the real base of our name. So we start from the pottery WASP because Massimo loved this super small WASP because it takes the soil to create hair domes. And this is a super good idea if we want to realize house with 0 kilometer material. So it's a sort of economical model for Massimo. And he immediately starting to try to find the best way to do this at our scale. And to do this, Massimo Moretti decided to start by studying 3D printing, because this is a sort of a super micro biological 3D printer, and which is the way that the pottery WASP use to create houses. Massimo starts 6 years ago with the crane, that 6 year, with the Big Delta. And 6 years ago, the Big Delta is the biggest machine in the world, and it is huge. But we immediately understand that there is a lot of limitation. There are a lot of limitations related to the 3D printer, to the Big Delta, because it's too big and the printing volume is not really big. The Big Delta, as the name said, is related to the Delta robot. And the Delta robot is a very fast robot, but is not a robot for large scale. So we decided to go back and try taking inspiration by the crane, the normal crane that you can see in all the building sites. And by this inspiration, we, in 6-7 months, we realized the first version of the crane WASP that is not this, but is very similar to this. This is the machine that currently we use in the building site. And is a modular machine, so it's very fast. We can create the setup for printing in half a day, and it is possible to close the machine inside the container, a small container, and it's very easy to transport that machine. And in another container, we develop all the stuff to start from the soil and go to a printable paste. And to do this is not very easy. We work a lot for several days in these years. And yes, we start from the excavation of the building site. And first of all, it's important to have a right soil in the building site. Not all the soil in the world are good for this process. We are working to create a setup able to be adapted in different conditions. But yes, I want to be clear. Nowadays, it's impossible to print with the soil all over. But when it's possible, we start from the excavation, and we have to dry the material after the excavation. And by using a disc screen separator, we obtain an homogeneous granulometry of the soil. It is very important when you have to print, because it is needed, because otherwise you could have a lot of problem with with all the part of the 3D printer. And when we have an homogeneous soil, we start the mixing phase. So for the mixing, it is super strange, because in our process we are frequently involved in a sort of strange paradigm, because we have high technology like 3D printing and low technology like the whole techniques related to the earth construction. So for mixing, we use I don't know, the wet pan mill. In Italian is molazza, and is a super old machine, is a Roman machine, is a sort of mill, but it's the best way to have a super homogeneous material for 3D printing. So we mix the soil inside the wet pan mill by adding natural fiber like straw and the rice husk. We use the straw from the husk because is super resistant to the water. No, the rice burn inside the rice grow inside the water, so it is super resistant to all the agents related to the water, and a percent between 9 and 5% of not cement, but is chemical additive to stabilize the soil. In our mind, we have to totally remove this part, but yes, in the mind of Massimo and in the mind of us, do is more important than think. So if we want to do something, now this is the only way to do. But yeah, we know that we have to remove this part of chemical additive just to be more green and to be more online with our planet. But yes, this is the start. We use lime to stabilize the soil, so it's not the worst material in the world, but yes, we want to remove it. And yes, in the second container, we have the crane. So inside the second container, we have the crane system and the continuous feeding system, that is a pump able to pump all the material for architectural scale. So if it's needed because client want it, we can pump concrete. Otherwise, if the construction is for us, we pump other kind of mortar like paste based on soil. And yes, the crane, I think the biggest feature of the crane is that is a modular system, and we could use more than one printer together. so is a multi-nozzle printing. And this is a very good option if you want to go very fast, because you are not related only to one nozzle in all the printing area. Because normally when we think about 3D printing, we think about a very small machine, no, with nozzle of 0.4 millimeter. In that case, you have to imagine that you are using nozzle of 30 millimeter, and you are printing a cubic meter of material. So it is very important to have multiple printer, and if you have a problem with one printer, you could print with the other one, so you never stop the building site. Just to show to you something about what we have done in this year, WASP don't develop only machine, because it's very difficult to show the potential of the machine if you don't print nothing, no? So my team is related to the to show to the people that it's possible to create a new kind of architecture, more biological. So Gaia is the first one construction of WASP, and is very close to our facilities. And this is the start of Gaia. So we started by try to find the best toolpath for our machine, because it's a super beta version of the crane. So we have to understand which is the best toolpath to be fine for the machine. And yes, this is the results of some months of research, and we decide to create a wall with multiple functions. So we embed inside the wall the ventilation system you can see in the up part of the design of the drawing. Inside we put the insulation, and to insulate the wall we use rice husk with a very small percent of lime to stabilize the rice husk. The mouse love the rice husk, and yeah, we made some tests for the transmittances of the wall, and it is very good. So we can imagine that if we create a normal house with this kind of wall, we have an A-class wall. So it is very good. And so with this, we decided to create a shape able to cover an interior area, an interior foot area of 20 square meter. So this is at the time is the maximum printable area of the machine, and we print it in 100 hours. So as you can see in that design, we create a system to create a natural ventilation along the wall. So we take the air from the north, we put naturally there is a ventilation from the north on the base of the house, and when the sun warm the surface, the external surface of the wall, we have a natural ventilation able to cool down the interior temperature. And this is the first building site, no? It is super basic. As you can see on the left, we have the excavation site, and we are very close to the 0 kilometer architecture now, because if this is the excavation site, we are very close to the mixing site that is at 20 meter. And in the center, you can see the crane, the beta version of the crane that was here we was printing. I think that this is the third day of printing. And yeah, this is now, which is the situation inside Gaia. So as I said, the wall is not a structural wall, so we use a timber structure to create the roof and all the column needed to the roof. And yes, this is an image of the exterior. And after 3 years, we are super happy to say that we have no problem. In that case, we use a 4% of lime to stabilize the clay. And yes, it is perfect, the wall. So we have no problem in this architecture after 3 years. So it is super, we are super happy of that results. And yes, the project that we are involved in the last 2 years is TECLA. And yeah, to make this project, we have a lot of partner. Because for Gaia, we work in particular with Rice House, an Italian startup that create material by using trash from the rice production to create material for architectural scale. And in that case, we have a designing partner that is MCA, Mario Cucinella Architects, one of the biggest Italian studios. And a lot of our partner for the research, we have SOS. For the material, we have Mapei, one of the biggest chemical company in Italy. Milan Engineering, that provide us the calculation of the structure of TECLA, and a lot of other company that help us to arrive at the final step of TECLA. To do this, we start as the stand from the material. I say sorry because I don't know why, but I have the Italian version of these infographics, but I can explain you. The red part is soil, the blue part is water, and the other part, the yellow, the dark green, the orange, is the chemical part. Only in the mix number 6, you can see a big green part that is related to the sand, because in our soil, we haven't a huge quantity of sand inside it, and we needed to put inside the mixture just to reduce the shrinkage of the material, because if you want to naturally reduce the shrinkage after the drying process, you need to use aggregate like sand. After that, we start working with the engineer to understand which is the best solution to create a dome. So, which is the best structural section to create a dome. And we decide to work in that way. As you can see, for the calculation, the engineer use only the blue part of this design. The white part is more related to the 3D printing. Here you can see 3 different sections, bottom, medium, and top. And as you can see, we reduce the material from the bottom to the top. And this is possible thanks to the 3D printing, no? Because you can change the quantity of material inside the percent of infill, as Cura or Simplify 3D said. So in that case, we don't use software like this. We made all the toolpath for TECLA by using Grasshopper, because yeah, it is super software and it is free. So I like it. And we use this, and in that case, we reduce the material, no? I don't know if you know the Pantheon in Rome, and the Roman, to do this, to reduce the weight of the material from the bottom to the top, they change the type of aggregate. So they start from stone, and they arrive at pomice, so it's a lavic stone, super light. In our case, we reduce the material, so we reduce the number of toolpath of shell inside the printing toolpath. And the other part is filled with rice husk, as in Gaia. This is the first test, is of 1 year ago, and here we have to test all the designed thing, no? Because in our works we have the concept phase, we have the design, phase. We have the prototypation. So we create some small model. 3D printing in this is very, very beautiful because you can scale all the thing now, because this tool, I can scale this toolpath and reprint in small scale and see a lot of super interesting things. So in that case, this is the step when we go from inside WASP to outside WASP to test. So as you can see in the left, there is one of my colleagues, super confident with the pump. And yeah, after the printing phase, we test it for 1 year under the action of the climate change, and to understand if it's possible to have a structural wall made by using soil outdoor without a timber structure over. And to hydrophobize, to create a sort of hydrophobization of the surface, we use a Silosonic product that is an hydrophobic product. So it don't cover the surface. This material creates a sort of reaction that put out the water. So the water is very fast on the material, and the water haven't the time to go inside. So after that, the architecture studio start immediately to say, okay, it's possible. Now we have to create a village. And we said, no, okay, not the village now. We can start from one TECLA and not from the village. So we decided to start with TECLA 1 year after the mockup. And this is basically all the function embedded in TECLA. So as in Gaia, we try to put all the needed function inside the wall. And so we have ventilation, and in that case, we have the structural system, and we have the design system. So in which way we want to create our interior experience. Here, there is an infographics just to show that for one more time, our works is divided in high tech and low tech. So in the left, you have the high tech part that is reusable. So the window, the furniture, the door are all part reusable, made by using glass and wood. And on the right, you have the biodegradable part that is made by using soil. So this, in that case, is the high tech, low tech is related to the material. This is some picture of the building site. We stay in the building site for 3 months. The total printing time is 250 hours. And in September, we print the last layer, and it is a super party. It is incredible. We are super happy to close this incredible print. And yes, now TECLA is finished, and we have the furniture. We have 1 tree inside, just to be more green. And yes, this is some. It's not render. This is the reality, and those are some images of the interior of TECLA. We aren't inside WASP now, as I said with Elizabeth previously, because now we are in a building site in the middle of Italy, and we are go back to squared wall. So this is the project that we are printing now, is for a client that want his house. And yes, we use a lot of big machine, because now the material is a lot. We print 50 cubic meter of soil in that project, so we need big machine to move all the soil that is needed. We use the maker economy to move our crane, so the process is the same that I show in the infographics in the starting part of the presentation. And yes, we print for this project. We start printing in January and February, so we need a cover over our machine, because it's very difficult to print. It's not difficult like in England in winter, but it's difficult in Italy too. So we, for the first time in our experience, we print with the crane indoor, and we start printing the wall of the house. It is a wall with incredible performance in thermal performance, because we have a transmittances of 0.18, so it is very good. And yes, I hope to finish the building site next week. So next week I'm back here to close the last part of the work. This is a super. It's not public. This image is only for you at the moment. Okay, and this is I started with my field of research, but now I want to show you more about what we do in WASP, because we are not only houses. And as Massimo frequently said, we are not so crazy to think we can work, but we are crazy enough to work for it. So all day Massimo try to start with new project to help the world. And this is possible by an incredible team, because we grow during the years, and now we are around 40. And our fields of research is this. We start from the food, because for Massimo, obviously, if people haven't food, it's impossible to do nothing, no? After that, if you have food, you need an house. And after the house, you need the health, the energy, the work, and finally, but not finally, art and culture. Massimo said that art and culture is the base for all. I think that Massimo put art and culture very close to food, maybe because for Italian, art and food are very close. And yeah, this is our space. So this is where we work. Outside where Massimo writes Shambhala, now there is TECLA, and you can see here, you can see Gaia. This is the space where I work, that is the R&D part, and this is the part where we produce the 3D printer. So we have our vision, we have the project, and we have the product. It's a sort of circle, and if we have good product and we sell that product, we have the money to have a biggest vision. So it's a sort of a continuous circle where we work in the middle, in my case. And to do this, we create a WASP hub network around the world. So we have a lot of network around not only Europe. We have one hub in London, Arthur Mumani Architect, and other around the world, because it's very important for us to create a network. We start from the open source. So for us is the base to create a network of different ideas to take the best to go in the right way. I try to explain more about the other field of research in WASP. Is not close to me, but I know a lot of things about that. Food. The first one is WASP Hortus, is a project that I'm involved in, and is a column for hydroponical culture. And yes, it is super beautiful because it's a project developed in Rhino and Grasshopper, and it is possible to change the dimension of the column and the number of the cavity to put the vegetable. So it's a total custom project, and you can modify what you want and print it. So by using 3D printing, it is very easy to create a different configuration of the same logic, and it is adaptable to the different configuration of the house of the client that wants this. And to do this, WASP developed the Delta WASP 3MT, a machine able to print at large scale polymers. In the food, we have a client that wants a 3D printer able to print chocolate, and in particular to print over the egg. So we develop a machine able to print chocolate and in not planar condition. And at the same time, with the same machine, we starting test if it is possible to print biscuits. So the machine is this, it is born to print clay, but we understand that it's very similar, the paste, the alimentar paste the alimentar pastes are very similar to the clay, and we start to modify that machine to print food. On the side of the health, we develop the digital orthopedic laboratory, first of all. And yes, this with this, we develop in Blender, so another open source software with Alessandro Zomparelli. We develop WASP Med add-on for Blender. It is an add-on made by to give the possibility to doctor to design what they want, because now, as you perfectly know, nowadays a doctor don't have all the information to go on Blender and to create a 3D model. So we use this add-on to simplify Blender for a doctor, and to give to a doctor or to a technical medical people the possibility to work on this super software and to create printable model. And with this, we create that first test, but now we have a lot of clients that use our printer to create body braces. And during the COVID, as all the people in the world, we need a face mask. So with the same add-on, we realize a special feature to create your own mask. So if you scan your face with that add-on for Blender, you can design your face mask so that perfectly fit your face, and realize in 2 hours your mask. We print a lot of it for the municipality of Massa Lombarda, the place where WASP is based, because in the first time of the pandemic, we haven't face mask. So a lot of people like policemen and other super important people for the municipality of Massa Lombarda need the face mask. And we use this to help Massa Lombarda. And to do this, we use the Delta WASP 4070, that is a machine able to print technical material at large scale. We made the present to the hospital of Damascus in Syria, and we give to they one of the 3070, and they use it to create ortheses and protheses for people that need it. In the energy side, we have a lot of idea, but for Massimo, it is very important to use one low energy material, so to recycle plastic, because Massimo said we use a lot of energy to create plastics, and it's important to use that plastic not only one time, but to reuse it more as possible, much as possible. So we start from polypropylene, and we realize this wind turbine able to create a new energy. So this wind turbine is totally made by using a polypropylene recycled pellet that we have developed with an Italian company. And it is super beautiful because in this material, the 20% of this material is taken from the sea. So it is we are super happy to use this. On the side of work, we develop a lot of small machine like the 2040. That is a machine able to print very fast a lot of technical component with tech material. And in the case of Technogym, we collaborate from several years with Technogym to create the first version of new products in Technogym. And in other case, like Ital Drone, they use our machine to create a serious product. So our machine now is on the market to create a serious product, able to create a super high performance drone. Finally, but not finally, art and culture. I don't know if you never see this, but this is an installation of Arthur Moumani, an architect and a friend. He is based in London, and he is our WASP hub in London. And this installation for COS in Milan 2 years ago. And I think that, yes, it is a super beautiful spatial performance. But one embedded information that I want to give to you is related to the fabrication process of this. Because Arthur created the design in London and used 5 WASP hubs to create this installation. So the design is made in London, but the fabrication is made in Madrid, Barcelona, Venice, and I don't remember, in the middle of Italy, Urbino, I think. And yes, so the production is locally, more close to Milan, and the design arrived from London. No, so it is very beautiful when in the WASP hub you have the same machine. It's possible to create the design in one place and the fabrication in another place. So only the information are around. The fabrication is local. And another project with Arthur is related to the Burning Man Festival in 2018. And in particular is related to the lamp inside the Galaxia Temple. And I was involved in this project because Arthur created the design in London for the first time. And I released the G code in Massa Lombarda, in the WASP facilities. And I sent the G code in Reno. So the fabrication is in Reno, and the optimization in Massa Lombarda, the design in London. And Arthur have seen for the first time the lamp in Reno. So he never see the final results. He only see the final results super close to the installation. And in my opinion, this is super beautiful. Yeah, for the Opera of Rome, we realized this scenography. This is my first work in WASP. I was super young when I do this. And yes, it is very, very big because it is 20 meter large and 5 meter tall. So we spend a lot of time and we develop our machine during this work. In the first stage, the machine are very close to the perfection. In the last part of the work, we are very close to have a very good machine. So as we frequently do, we develop the machine during the work. And finally, that work that I have made with my super friend Andrea Salvatori, and it is Ikebana Rock and Roll, is a series of vase that explain the iteration between machine and artist. So I, as WASP part, I create the G code of this vase, and Andrea put continuously these spheres around. It is a sort of war between Andrea and the machine, and yeah, the results, in my opinion, is super strange. No, it's a sort of new aesthetic because it explains this fight between artist and machine. That vase was in London now. I don't remember the name of the gallery, but now that vase is in London. And yes, that all from WASP side. Thank you for the attention.
Oh, thank you, Lapo. So many things. I don't know where to start with the questions, but I guess what we'll do first is take a 5-minute break, and that will allow all the participants to potentially think about any questions that you might have for Lapo, and we'll come back in 5 minutes for a Q&A session. Welcome back, everyone. I think we're ready to move on to the Q&A session, and I've just checked the chats and you've added quite a few, so I'll just go on the first ones. So Lapo, is there any possibility to get further information on the structural approach, particularly the structural material parameters that were assumed? So compressive strength, E-modulus of the treated loam clay of the TECLA house?
Is not microphone. Okay, microphone is okay. Perfect. Sorry. And yeah, I mean, is not my focus in this research, the material, but yes, I have the information related to this. We use for TECLA 42 cubic meter of material, and this is because the performance of the material is not really high. We are around 1.5 megapascal, so it's very low, but is enough for this structure for the engineer, because we use a lot of it. So it is a sort of balance between the cost of the material and the quantity of the material. Because now, if you use mortar concrete, it is very easy to have high performance, but you have high cost. In our case, we want to reduce the CO2 emission and the cost of the material. And to do this, we decided to use a huge quantity of soil. Yes, of course, I know that nowadays is impossible in the time of the TECLA project to arrive to have a sort of validation of the structure by the with the regulation of Italy, no? Because in the code, in the Italian structural code, there is nothing about the soil and nothing about the 3D printing. So if you put the two things together, it's very difficult to arrive at the final stage of the validation. I know. But when we speak with the engineer, the idea is, okay, we want to create something that we are sure that we have no structural problem in any case, wind, earthquake, and all the static problem that we could have. But it is only to show the actual state of our technology. It is not ready to go in the market, TECLA. The other project, yes, because if you haven't a structural wall, you can use it just to close your house and not as structural wall. But in the case of TECLA, it is only a test. So we want to show, but it is not ready for the market. So I perfectly understand the question related to the material. So I said, the resistance is between 1 and 2 megapascal. But yes, it is enough to be sure that we have no problem, but it is not good if you want to arrive at the validation from the authority.
Okay. Yeah, that's really interesting. And just moving on to the next one, we've got many compliments for you, Lapo. So everyone's has been really enjoying the talk. So yeah, thanks again for that. And just moving on to the next question from Stephanie. So, is there any structural or ecological benefits to using local clay? So understanding that the local production saves energy and wastes in transportation of material, etc.
Yes, we try to make an LCA validation of the process, and it is incredible because the biggest quantity of emission of CO2 is related to the sand. Because, as I said previously, we need to use not a huge quantity, but a good quantity of sand inside our mixture. And the biggest emission of CO2 is related to this, to the transport of the sand, because the weight is very high. So yes, as I said previously, WASP and Massimo decided to use the soil for this reason, because we want to reduce the emission and we wanted to create something very close to the biodegradability, no? Because now we create a lot of super green building, but I haven't, it's very difficult to see a building able to come back to the nature in without the use of a huge quantity of energy. No, if you need to destroy an house, you have to separate all the different parts. No, the plastic, the glass, the wood, the cement, the metal. In our case, we try to use the lowest quantity of different material that is possible. As I show in the slide with the infographics on TECLA, we have two different parts, high tech, low tech. In the low tech, we have straw, husk, and soil, and the 9% that we want to remove of chemical additive. But the other part is good for our houses. So in our mind, we want to create something that is very close to a nomadic situation, because you can remove the high-tech part from the house and you can leave the house. You can leave the house and you haven't problem in the biodegradation of the house. You don't need energy to degrade for the degradation of the house. This is our main goal.
Okay, that's great. Thank you, Lapo. Moving on to a question from Kathy. What's the platform or base that you build your houses on? Is it directly on soil, or how do you manage that?
We print 10 centimeter of concrete. So we use the basement of TECLA to show to our possible clients that we are able to print concrete. We don't print only concrete for the reason that I previously said, but we are able to print it, and to divide the base of TECLA from the ground, we use 10 centimeter of printed concrete. So we reduce more than is possible, much as possible, the dimension of this foundation, because it is only under the walls. In the center, we have nothing. There is only big stone, and the bottom is made by using soil. So it is all made by using soil.
Okay, that's great. And I guess that's where you could plant a tree as well in the house, which looked really good. So moving on to the next question from Stephanie again. So can you use local materials or soil in any part of the world, or is there a certain chemical or material quality that is required? So something that you would maybe find regionally in Massa Lombarda, or is it something that we can do pretty much anywhere?
Yes. In that process, is necessary to understand which is the base, no? So which is the raw material that you find, and yes, after that you have to decide which is the best way to arrive at the goal, and we perfectly understand that all the soil is different, sorry. And it is very important to create a sort of protocol to arrive at the mixed design. And yes, in our case, in Massa Lombarda, as I said, we needed to use sand and the part of chemical additive, but in the building site that we are now, so now we are using 4% of Mape soil, that is the chemical additive. And yes, it is a more natural wall than the one of TECLA. So we are very related to what we found in the building site. And yes, I think that this is the answer. Yeah.
Great, thank you. So another question from Kathy. How big does the site have to be to take all the equipment around the actual build?
Ooh, good question. We have two containers, small containers. So the small container is 20 feet. I don't remember, 20 and 40. See, yes, something like this. So we have two containers of 20 feet. The dimension of the crane is a cylinder of 8.5 meters of diameter. And yeah, the requested place around the construction is not really too much, because in the building site of TECLA, in the video on the website, you can see a lot of things, but I think that is a place of 40 meter and 20 meter. It is not really big. Yes, we close the excavation site just for security reason. But yes, in the initial idea, we want to use the excavation site to create a small lake. But yes, we have some problem with the municipality, so we have to close the big hole that we create to excavate for the excavation. But yeah, it is very close. It is very close to TECLA and is not big. So in a space, the interior space of TECLA is 40 square meter, and yes, around TECLA we haven't a lot of space.
Okay, that's great, thank you.
Yes, because in the case of TECLA, we use all the printable area. So it's impossible to stay with the pump inside the printing area. So we have to use a space outside from TECLA for the pumping system and the mixing system. In the building site that we are now, the name is Evolutional Farm, is in the middle of Italy. We can stay inside the construction with the pump and with the mixing site. So it is smaller than the building site of TECLA. It depends by the morphology of the architecture.
Yeah. Okay, that's great. And another question from Maria, specific to the Gaia house. How does it behave structurally in the event of an earthquake?
Yes, for Gaia, as you can see, we create a space between the timber structure and the wall. So it is totally independent. So in case of an earthquake, the soil and the timber structure don't have any kind of interaction, because it could be very dangerous for the soil to be in contact with the timber. And so with the engineer, we decided to divide these and to calculate that if in the worst case scenario, the wall go inside on the columns, the columns are able to sustain the weight of the wall. So this is the idea that we have for Gaia.
Okay, great. So moving on to a question from Kim for Lapo, or perhaps someone else in the audience, thinking about the rice husk insulation and adapting to another geographic location such as Plymouth, what other materials might have the same qualities?
Yes, this is a good question, because in our mind, we have to create a sort of biodiversity around the world, no? So we use rice husk because in our region, we have rice husk. We are in the Pianura Padana, so we have a lot of rice. And I know which is the best material that you could have close to you. But yes, the historical construction teach to us a lot of things. Another case possible is, so in Portugal, you could use cork because they have a lot of cork and it is perfect. In other country, people have coconut tree, so you could use coconut fiber. So I think that is very important to destroy this paradigm of same material around the world. We have to understand that if we wanted to be ecological, we have to try to find the best solution local. And I know that it is difficult, it's not easy, and we try to do. We are not perfect, we try to do our best. But in our mind, the idea is to find the best receipt for all the place.
Yeah. Yeah. I think you gave another example earlier in your presentation when you said that the design is sort of made globally, and then you try and sort of make and manufacture locally, which is fantastic.
Yes, because it's incredible in the project of with Mamouani for the Galaxia Temple. Is incredible because you perfectly know, no? Around the world now, bioplastic is the future, no? And PLA in particular is the best bioplastic, no? For who sells that kind of plastics. And it is incredible that the biggest place in the world that produce PLA is very close to Reno in the USA. So if we want to produce the same lamps in Massa Lombarda, the material burn in USA, go to Massa Lombarda and go back to Reno. And this is impossible. In that case, it is a super lucky solution in our case because it is very close to Reno, the industry that produce PLA. But in our case, yes, is a lucky case, and we have the production very close to the production site of the material, very close to the production site of the lamps.
Yeah. Great. So got another question from Stephanie, quite related to the one we had from Maria, I think. So given that Italy has many building requirements related to earthquake, is TECLA resistant to earthquakes, or is there something in using natural materials in this way that adapts to seismic tremors and other earth activity?
Good question. Yes, as I said, the engineer take in consideration the possibility of earthquake, and so in the model, in the calculation model that they made, they take in consideration earthquake. As I said, for the regulation, it's impossible to clarify all the aspects of our solution, because we need more and more tests on the material, not on the material, but on the block of the walls. So it is a very long way to arrive at a validation from the state. So yeah, we have a lot of material to be tested to improve the structural resistance of our wall. More are natural, other are less natural. There is a lot of natural glue, super interesting, like it is made by using the resin of the pine. And yes, we have a lot of scheduled tests for the future, and we want to go in that way to improve the structural resistance, in a lot of different aspects, like using other type of natural fiber, because now we are using straw, but the mechanical adhesion between the straw and the soil is not perfect. So we tried in the past to use different type of straw in order to improve the mechanical adhesion, but maybe the chemical adhesion between clay and fiber is better. There is a lot of aspect. As I said, we start with this mixed design that is not perfect. But yeah, I want to be clear, and it is I want to say what we have used, and it is chemical, and 9% is chemical. And I think that this is only the first step. Yeah. I work in WASP from 5 years, and I think that in these 5 years we made a lot of innovation in this field, and I need more time, and yeah, and more people that work with us maybe. So yeah, this is the starting point.
Yeah, absolutely. And talking about straw, I've just seen on the comments, Jason said that we have a lot of straw locally here in Plymouth, so it might be something that we could use for the installation if we wanted to do that locally. But moving on to other questions, and the list is fairly long, so thanks everyone for adding questions. It's lovely to see all of them, and I hope that Lapo is answering well to you. Feel free to jump in if you want to have more details as well. But just moving on to Glenn's question. So what, I think you mentioned about this earlier in the presentation, what chemicals do you use to repel water for storm weathering, and what is the cost of building using crane WASP, and how do you anticipate the costs will sort of decrease with time? So it's a bit of a two questions. Yeah.
Okay, it's very difficult to speak about cost because by now we only sell a machine to one university, the IAC of Barcelona, and it is a special price for university. Because now Massimo Moretti loved to work with the university because the university are the future. And so now I haven't a cost for the machine. I think that we have to understand the cost of the time, because as I said, we spend 250 or 60 hours, I don't remember, to print TECLA. So we have to understand which is the cost, and I know that to fill the pump with the material, it is needed to have 2 people in the building site. So the cost of 2 people that provide the material to the machine, and maybe the cost of the design of TECLA, because now there is a designing phase very long, and maybe the cost of a supervisor, because for 1 or 2 hours a day, it is needed to have a technical or an engineer able to check if all the things are going in the right way. So the cost, I think, that is more related to the people than on the machine. On the material side, as the same, because as I said, in our case, our mixture haven't a cost, because the cost is only related to the 9% of chemical. And yes, it is very, very low. It don't cost so much, so it's not a problem. Another, the energy is not too much, because we spend for all the building site with 2 machines, 2 pump, the mixing system, the filtering system, we use 9 kilowatt. So is not a huge quantity of energy. So yes, I think that at the moment the biggest cost is related to the people that work in the building site. And yes, is an R&D project, so we are working to pushing up the speed and pushing up the autonomy of the material of the 3D printers, because now for TECLA is the first time for ASMA, I think is the first time in the world that people use together 2 3D printer. And the synchronization of 2D 3D printer at architectural scale, I think, but I'm not totally sure, but I think that it is the first time. So we are 3 engineers, 20 hours a day in the building site to check if all the things are going in the right way. In the future, we don't want to have 3 engineers in the building site, because we aren't very, very, very. Is not our place. And yes, we are trying to create an autonomous system for the filling of the material. So we want to arrive and to the creation of the material without the help and the power of a human. So we are working to reduce all the boring in the building site.
Okay, that's very interesting. Thank you. A question from Kathy. Thinking about where housing needs might benefit best from your construction methods, is WASP looking for partnerships between governments and private investors to bring these houses where most needed?
Yes, we are looking on it, and it is not easy. I was speaking yesterday with Massimo and Francesca Moretti about that, and yes, because it is a work, no, to find the best way to create a collaboration with government and private. It is a huge quantity of work, and in WASP, by now, when we have a problem, we try to solve with our energy the problem, and we don't find the way with the government and other private company. And I think that the two-way needed the same effort, and I think that we have to find a way to put together this two-way to go faster to the goal. Our mind is very close to the maker mind, I think, because when we have a problem, we try with ourselves to solve it, and we have to become more company for in that way.
That's great, thank you. So moving on to the next one from Benjamin. How many people are required to operate the machine over the 250 hours printing process? I think you mentioned about the 3 engineers.
Yes. Now that the code are validated, because we tested all the code for TECLA, is needed 2 people for filling the pump. So no technical people in the building site to check the machine, because now we have a webcam scanning system, so we can check from office if the machine are printing in the right way.
Okay, that's good to know. Thank you. Another question from Ginny. So cost question. Assuming the site soil is of suitable quality and additional soil is not required to be imported to provide the building paste, how much roughly to build 1 square meter of wall?
3 hours for TECLA, because the wall is structural. So we have sorry, but I immediately start to the number, because I have the number in mind and I want to go to the number. Okay, in 3 hours we print a square meter of wall with 20 shell, because it's structural. If we can reduce the number of the shell, we dramatically reduce the time. So we can arrive at 1.5 hours for one square meter. Another thing is related to the time for the changing state of the material, no? Because we print a paste, and to go very fast in that direction, we need that material is strong. And when you print with plastics, no, so in the FDM process is very easy, because in 2 seconds the plastic go back to be solid. In our case with soil, we need 5-6 hours to go from paste to rigid material, and it is possible thanks to the chemical part. If we reduce the chemical part, we enlarge the time for the changing. So more is related to this.
Okay, and I think Ginny wanted to have a rough idea about the cost as well, but I guess it's difficult to say.
It is very difficult because, yeah, okay. I mean, if we imagine to have one people for one machine that print 1 square meter, I don't know which is the cost of one people in UK. In Italy, we can say, I don't know, 25 euro for 1 hour. So if we invest 2 hours for print a square meter, 50 euro, something like this. In the case of the earth, I don't want to speak about the cost of the material because it's nothing. Is really nothing. The cost is related to the people.
Okay, great. And another question from Benjamin. It's about the machine cost, but you mentioned earlier that you're not really selling publicly. So
exactly.
yeah, that's all right. Moving on to another question. So from Jason, have you considered adding paper pulp to your mix? The unfired compressive strength of paper clay is typically around 4 MPa. The strength is provided by the cellulose.
Yeah, we use the cellulose when we print clay with our machine for the clay.
Okay.
It is very, very nice because you can go very fast and you have a super elastic material. It's super nice. The use of cellulose and methyl cellulose. In our case, we made some tests, but it reduce this component push up the time for the drying process. So we have to print more slow because it is a sort of sponge for the water, no? So you take inside the water and you haven't a fast changing of the state of the material.
Okay, thank you. Another question. So I guess we've got another 10 minutes for before we wrap up. So thank you, Lapo. You just moving from one question to another here, and we'll just continue. So Adeli is asking, what's the next step on the journey to making TECLAs available to private owners? Or should I rephrase, what needs to happen before I get my own TECLA house?
You want my idea or the company idea? No, I try to replay with to answer with my idea. My idea, and we are working on an agreement with the other partner of the TECLA project, is to invest 1 year in testing at a small scale. So I want to produce a huge amount of samples, and I want to destroy all the sample in a different way. For the resistance in one way, for the durability in another way, for thermal stress. I want to test at small scale in a real different direction in order to have more data. Okay. Another part during this year, this is my work in the next year. So working on the not really in my side on the material, but in which is the best way to put the material in the space. Another part of this year research is on the mix design, because as I said, we want to reduce the chemical part. So we have a lot of idea, but I want to test it because an idea is an idea, a test is a test. So, okay, beautiful ideas, but if we haven't the test, it's impossible to create a house for private people. So in parallel, we have to work on the material, and in parallel too, we have to work on the machine because we understand something about the crane that we have to change. And it's not a totally new design of the crane. It is a lot of small part that we have to change in order to be more faster and to reduce the amount of water inside the mixture. This is the biggest revolution that we have to make on the crane. We have some ideas, and yes, I hope that in the next 3 months we are ready to test this upgrade of the crane and understand if we have found a solution. Because yes, it is very difficult, because in our company we continuously test for 1 or 2 hours one things inside, and after that we put it in the building site. But the building site is the worst case scenario for a new technology, no? Because if something can go not in the right way, be sure that it happened. So it's not. We are very fast to arrive to materialize the idea, no? Because we have a lot of super maker inside WASP, and all are able to create something that could work. And the building site need more time, because no, otherwise we lost a lot of time in the building site, and I prefer to lose time inside outside.
Okay, so Adeli will have to wait a little longer, and
yes, I hope that in 1 year we are ready to have a good solution. Yes.
Okay, that's great. Thank you. And moving on to a question from Jocelyn. What is the resistance in time to rain, especially for the TECLA house?
We are testing this. I mean, the Planisil that we use for the hydrophobic coating that we have in TECLA is guaranteed for 10 years. And I don't know at the moment. At the moment it works. But for the future, I want to test with accelerate test, which is the durability of this system, because I think that we could have invented the problem that is not easy to see in 1 year, in 2 years. So it is very important for me to test it and to understand which is the real durability. If you take a look to the ancient architecture in Africa, people have a sort of religious practice related to put new soil over the church or over the houses. No, all here people put new soil over, because it's normal. No, you are using a super cheap material, but if you want to have a perfect shape, you need to replace in all the time the soil over. And yes, I think the technology could help in this aspect, because no, a lot of techniques was abandoned in the time because of the cost of the because in the time to be sure that they work in the time. And if we imagine to use I don't know, but small drones or small other robot able to put soil for us over the TECLA's house, we could imagine a total natural shape, because we have in continuous a small drone or a small rover. I don't know. I was just imagining with you, able to take soil and put it on TECLA. When the robot see that there is a crack, there is a small hole. So I think that in the future we have to work on this. So in the automation of the restoration phase, and it is a continuous restoration, no? Because now in Italy we are super clever with the restoration, but we made the restoration after 100 years. In that case, I think that is important to make a continuous restoration, like in Africa people do with ancient architecture made by using soil.
Yeah, absolutely. That's great. Thank you. Another question from Jason, and that's on the behalf of us at Plymouth College of Arts. Could we do a research project with you?
Sorry? I was thinking.
Yeah, no worries. So yeah, that's a question from Jason, and that's really on the behalf of us at the College of Arts. Could we do a research project with you?
Yes, of course. Yes, as I said, WASP is super open to collaboration. So yes, we are super open to discuss with people about ideas and about possible projects to made together. As I show in the presentation, we have a huge quantity of collaboration in all our projects. So this is our mindset.
Okay, fantastic. So we'll be in touch with you after this. And I'm only going to take maybe a couple more questions, and then we'll wrap up because I'm aware of time. So a question from Morgan. Where do the MEP fit within the walls, and where is the bathroom?
I don't show the bathroom. Sorry. I have to check it. Just 1 second, please. 3dwasp.com. I try to check in our website. Is better than me. Okay. I try to present my screen. Here. Can you see my screen?
Yeah.
Maybe in the press kit, I have some image about the interior. There isn't image of the interior. No. This, okay. This is the door of the bathroom, but I haven't here image of the bathroom.
Yeah, sorry, Lapo, we can't see the other window that you opened.
Sorry. Okay, I have seen now.
No worries. No worries.
Ok, quindi devo interrompere qui, just 1 second. Okay. Now?
Yeah, that seemed to be, yeah, that's great.
Yeah, this is the door of the bathroom, and I don't know why we haven't the photo of the interior. This is Massimo and this is Mario Cucinella, the architect. This is the kitchen with the table. And this is the photo of the exterior. The bathroom is here. And I don't know why we haven't the photo. Unfortunately, in my computer that I have now at home, I haven't all the photo that the photograph made.
Yeah, that's all right. Don't worry. Moving on to, I think this is going to be the last question. So that's a question from Diogo, and he says, congratulations for all the inspiring projects that you're involved in. In the case of the domes, is it any structural reason for the windows being placed on the top?
I don't understand the reason why the
Yeah. So you've got the windows that are on the top of the houses on the TECLA, and
yeah, the
reason
reason is super technical because we need a hole to remove the crane.
Yeah, okay, yeah. That's very, very necessary.
Yeah.
Perfect. Yeah, we've actually got like, yeah. Do we take an additional minute or two for a last question?
One last, okay, the last.
Okay. Let's do one last from Manish. So, why did you prefer jib crane style over a gantry type printer?
Okay, the Ctesian. I prefer the crane just because it is smaller than the construction. I never see. The Cartesian system are super validated, and it is super nice. They work very well. But I'm not totally agree about the solution to have a machine bigger than the house. I never see a crane bigger than a skyscraper. People, when build skyscraper, put the crane over the skyscraper. You haven't a crane that starts from the bottom to the top. And I think that in that way, it's very important to have machine able to be moved by two people, because a crane, it is, we can move and transport a crane in with two people. And yes, this is the reason why I prefer, because it's very small. It is very easy to be assembled and disassembled. And yeah, we haven't a lot of columns, because the lowest quantity of columns is 3, and we use 1 for the crane and the other 2 for the electrical and water stuff, just to be clean in the building site. So yes, I think that our solution need less quantity of material to be ready to print in terms of metal.
Yeah, I see. That's yeah, that's very interesting. Thank you so much. Well, I think that's it with the question. I think we're ready to wrap up, and you deserve a good rest for firing up all these these answers. That's been fantastic to have you. And as I said earlier, I think we're going to definitely keep in touch. If you want to have a look on the chat, you've got so many people that are telling you thank you for such an inspiring talk. And yeah, it's been absolutely inspiring and super great to have you. So yeah, thanks to you, Lapo, and to all the participants as well. Thanks again.
Thank you so much for the time and for the opportunity to show our works. And yeah, keep in touch. WASP is open. So yes, thank you.